something happened on March 16th that nobody was ready for. The data came in quietly at first, just a stream of numbers from a spacecraft hundreds of millions of kilometers away. But when the scientists processed those numbers, they went silent. Then they checked again, then a third time. The result did not change. Comet 3I Atlas had just passed Jupiter, the largest planet in our solar system, at a distance of 53 million kilometers. It was traveling at 61 kilometers per second, and Jupiter's gravity had done absolutely nothing to it. The flight path of the comet had not shifted by a single measurable degree. That is the kind of result that stops a room, and once you understand why, it will stop you too. To appreciate what this means, you have to understand what Jupiter does to things that come near it. This planet is 318 times more massive than Earth. Its gravitational field is not a local event. It stretches outward across tens of millions of kilometers of space and dominates everything in its neighborhood. Over the long history of our solar system, Jupiter has pulled comets off their paths, swallowed some of them whole, and flung others into completely different orbits. It shredded the comet Shoemaker-Levy 9 into a chain of fragments before pulling each piece down into its atmosphere in a row of explosions. Jupiter does not ignore things. Jupiter reaches out and grabs them. But not this time. Not with 3I Atlas. The comet came in fast, passed close, and left without a trace of gravitational interaction. The Jupiter Icy Moons Explorer spacecraft was watching. Its cameras captured the comet in enough detail to see its coma and its tail clearly, and the trajectory data confirmed the impossible. This object had passed through one of the most powerful gravitational environments in the solar system and emerged unchanged. That single fact is the center of everything we are about to examine. But to truly understand it, we need to go back much further, because this comet did not suddenly become strange on March 16th. It has been telling us something unusual from the very moment it was found. The discovery happened on July 1st of 2025. Astronomers spotted a faint point of light moving against the background of fixed stars. That motion alone was enough to begin the mathematics of orbital tracking. Within a few nights of observation, the data produced a number that changed everything. The orbital eccentricity of this object was significantly greater than 1. That value, greater than 1, means a hyperbolic trajectory. It means the object is not orbiting our sun. It never was. It is passing through on a one-way journey, carrying too much velocity to be captured by any gravitational force in our solar system. After this brief visit, it will leave and never return. The interstellar origin of 3I Atlas was confirmed from almost the very beginning, but an interstellar origin alone does not explain the strangeness of this particular object. Other interstellar visitors have been detected before. What made scientists lean closer to their screens this time was the chemical signature that followed. On March 12th, spectroscopic instruments from observatories around the world were pointed at the incoming comet. Spectroscopy works by splitting the light from an object into its individual wavelengths. Every molecule in existence absorbs and emits light at very specific wavelengths, like a fingerprint made of color. When you look at the spectrum of a comet, you can read exactly what chemicals are present inside its coma by identifying which wavelengths have been absorbed. The spectrum of 3I Atlas produced a result that left researchers studying it for a long time before they were confident in what they were seeing. Methanol. In concentrations far beyond anything recorded in a comet native to our own solar system. Methanol is a simple organic molecule, a single carbon atom bonded to 4 hydrogen atoms and 1 oxygen atom. In comets born within our solar system, whether from the Kuiper belt or the distant shell of icy debris known as the Oort cloud, methanol is present in only trace quantities. It is a minor background chemical in a makeup dominated by water ice, carbon monoxide, and carbon dioxide. What the spectral data from 3I Atlas showed was methanol at a completely different scale. The absorption lines in the infrared spectrum were deep and wide, indicating a comet saturated with this organic compound. The significance of methanol goes beyond chemistry. This molecule is a precursor to life. Under the right conditions, exposure to ultraviolet radiation from a young star or cosmic rays traveling through the interstellar medium can break methanol apart and cause it to recombine into complex organic structures. Sugars, amino acids, the chemical foundations on which biological life is built. A comet carrying this much methanol is not just a frozen rock from another star. It is a time capsule of prebiotic chemistry, a preserved sample of the conditions that existed in some ancient molecular cloud billions of years ago, before the star that created this comet had even finished forming. The process that produces this kind of methanol enrichment happens only in the coldest, darkest regions of space. Temperatures barely above absolute zero. In those environments, carbon monoxide gas drifts onto the surfaces of tiny silicate dust grains and reacts slowly with free-floating hydrogen atoms over millions of years, building up layer after layer of methanol ice. The isotopic ratios found within the comet confirm this alien origin. Isotopes are variations of the same chemical element with different numbers of neutrons in their nucleus. Each stellar environment produces its own characteristic ratio of isotopes, and those ratios are locked into the material when it forms. The isotopic fingerprint of 3I Atlas does not match the Sun. It does not match any planet, moon, or comet in our solar system. The material in this comet formed around a completely different star, in a completely different part of the galaxy, an unknown number of billions of years ago. But the chemistry is only the beginning of the strangeness. Long before the methanol discovery, the comet's physical behavior had already started raising serious questions. Throughout February and into early March, observatories tracking 3I Atlas recorded something that should not have been happening. The comet was on its outbound trajectory. It had already made its closest pass to the Sun months earlier and was now moving away from our star and into the cold outer reaches of the solar system. The thermal energy reaching the comet from the Sun was decreasing steadily. Standard cometary physics is straightforward about what should happen in this situation. Less heat means less sublimation. Less sublimation means less gas and dust being ejected. A quieting comet that slowly dims as it recedes from its heat source. 3I Atlas did the opposite. Without warning, the comet produced a series of violent brightness spikes. Each flare ejected fresh waves of gas and dust into space, dramatically increasing the brightness of the coma. This happened repeatedly on a comet that was moving away from the only significant external heat source in the inner solar system. Something was generating enormous thermal energy from inside the comet itself. The explanation requires a detour into a type of ice that most people have never heard of. In the freezing vacuum of interstellar space, water molecules do not have enough thermal energy to arrange themselves into organized crystalline structures when they freeze. On Earth, water ice forms the beautiful hexagonal lattice structure we see in snowflakes because the water molecules have enough energy to settle into stable positions before freezing. In deep space, at temperatures just barely above absolute zero, molecules freeze almost instantly on contact with a surface. There is no time for organization. The result is what physicists call amorphous solid water, sometimes also called amorphous ice. It is structurally chaotic, a disordered glass-like solid rather than an organized crystal, and it is inherently unstable. When the comet approached our Sun and began absorbing heat, a thermal wave started moving slowly inward from the surface. Even as the comet later began its retreat and the outer surface cooled down, that wave was still propagating deeper into the interior. Eventually it reached layers of amorphous ice that had been locked in their unstable glassy state for billions of years. When amorphous ice reaches a specific critical temperature, it undergoes a spontaneous phase transition, reorganizing itself into crystalline ice. This transition releases energy. The process is exothermic, meaning that the ice itself generates heat as it rearranges, independent of any external source. That sudden burst of internal thermal energy rapidly vaporized pockets of highly volatile gases, particularly carbon monoxide and carbon dioxide, that had been trapped inside the frozen matrix for eons. The pressure built within the interior until it burst through the surface in violent outgassing events, throwing material into space and producing the unexplained brightness flares. These flares were not random, they were a window into the internal architecture of the comet. For gas to escape that quickly and in such large quantities, the internal structure of the nucleus must be highly porous and heavily fractured. A solid block of ice and rock would contain this pressure. It would take a very different kind of object to allow deep internal eruptions to rip so easily through its outer layers. The physical texture of this comet became even clearer during an event that took place on January 22nd. On that date, Earth's position in its orbit brought our planet into almost perfect alignment between the Sun and the receding comet. In astronomical terms, the phase angle between the Sun, Earth, and the comet dropped to nearly 0 degrees. When this geometry occurs, a measurable optical phenomenon takes place called the opposition surge. To understand why, imagine shining a light directly at a surface covered in fine textured dust. When the light comes from an angle, the tiny peaks and ridges of each dust grain cast small shadows behind them. Your eye or camera sees a combination of lit surfaces and unlit shadow zones. The overall brightness is an average of both, but when the light source is positioned directly behind you, those shadows fall exactly behind the grains that are casting them and become invisible from your point of view. Every illuminated grain is now unobstructed by shadow. The surface appears dramatically brighter. This is called shadow hiding. When the reflected light waves also travel back along the exact same path they arrived on, a second effect called coherent backscatter amplifies the brightness further as the photons interact constructively. This opposition surge event gave astronomers a precise measurement of the dust particles being shed by 3I Atlas. The data was startling. The backscatter signature matched material that is not solid at all. The dust grains surrounding the comet were not dense microscopic rocks or compact silicate particles. They were incredibly porous structures, fractured and irregular at scales almost too small to measure, more like microscopic fractal sponges than anything we would normally associate with a solid celestial body. The grains were mostly empty space, held together by thin bridges of organic material and weak electrostatic forces. The opposition surge had handed scientists a precise physical description of the comet's ejected material, and that description told a story about a nucleus built on the same principles. Now go back further still. On October 30th of 2025, the comet reached perihelion, its closest point to the Sun. At this range, the object was bombarded by intense solar radiation and a continuous barrage of charged particles streaming outward from the Sun at high velocity. The thermal loading on the comet's surface was enormous. The volatile ices boiled away at an extraordinary rate, ejecting gas and dust at speeds measured above 240,000 kilometers per hour. The outflowing material created a massive bow shock in front of the comet as it plowed through the incoming solar wind, similar to the wave pushed ahead of a ship on water. Any object built from normal dense material would have been stressed severely by this encounter. A fragile hyperporous body, one that flares and ruptures from its own internal chemistry, should not have held together through perihelion. Yet it did. On December 19, 2025, the comet passed closest to Earth at a distance of 270 million kilometers. For observers far from city lights, it became visible to the naked eye, a rare event for any object passing through our solar system, and even rarer for something born outside it entirely. The visual spectacle included a distinct green glow in the coma surrounding the nucleus. That green color is a chemical event written directly in light. When the comet's nucleus ejects material containing diatomic carbon, which is simply two carbon atoms bonded together, those molecules enter the harsh ultraviolet environment around the Sun. The UV photons kick electrons in the diatomic carbon molecules into higher energy states. Almost instantly, those electrons drop back to their resting state and release their absorbed energy as light, specifically in the green wavelength. This process, called fluorescence, is why the coma glows green. The green color never extends into the long trailing tail of the comet, because diatomic carbon is unstable under sustained UV exposure. The same solar radiation that excites the molecule also eventually destroys it through photodissociation, breaking the bond between the two carbon atoms before they can drift far enough to be pushed into the tail by the solar wind. The volume of diatomic carbon this comet was producing to create a naked eye display at 270 million kilometers speaks to the density of complex organic carbon chains inside the nucleus, carbon bonded in long chains, carbon forming the backbone of organic molecules, carbon in quantities that do not belong to a comet born in our solar neighborhood. Every observation, from the July discovery to the December naked eye display, to the January opposition surge, to the February flaring to the March methanol detection, pointed toward the same conclusion. This is a deeply unusual object of alien origin, rich in organic chemistry, structurally unlike anything in our own solar system, but none of that was enough on its own to explain what happened at Jupiter on March 16. The Jupiter Icy Moons Explorer resolved the comet's coma in enough detail to confirm something odd about its shape. A standard comet produces outgassing primarily from the sunward side of the nucleus, where solar radiation is strongest. The coma that forms around a typical comet is relatively spherical as a result. The coma of 3I Atlas was not spherical, it was elongated. Its shape has been described as an egg, a dense, opaque cloud with a distinctive, elongated structure that completely hides the solid nucleus from optical observation. The nucleus is invisible, not because it is too small or too dim, but because the gas envelope surrounding it is thick enough to block every photon trying to pass through. This egg-shaped coma suggested something unusual about how gas was flowing away from the hidden core. Not evenly outward from all directions, but preferentially along a specific axis. Whether this is related to the rotation of the nucleus, the distribution of volatile pockets within it, or some other factor is a question still being worked on. But the shape itself is a diagnostic clue pointing to a body that is doing something internally complex. Now bring together everything that has been gathered. Hyperporous dust confirmed by the January backscatter data, internal fracturing confirmed by the violent exothermic flaring in February, anomalous organic chemistry confirmed by the March spectroscopy, an egg-shaped opaque coma hiding the nucleus from any direct measurement, and a trajectory through Jupiter's gravitational field that registered no deflection at all. Gravity interacts with mass. This is not a subtle point or an approximation. The force of gravity between two objects is directly proportional to their masses. When Jupiter's gravity reaches out across 53 million kilometers of space, it is reaching for mass. If 3I Atlas had the kind of solid dense nucleus that its large gas envelope visually implies, that mass would have been there for Jupiter to pull on. The trajectory would have bent, the deflection would have appeared in the telemetry, detectable and measurable. It did not appear because the mass was not there. The nucleus hidden inside that dense egg-shaped coma is not a solid block of ice and rock. It is a structure built on the same principles as the dust grains detected in January, a massive fractal sponge of amorphous ice, organic molecules, and loose dust with an extraordinary proportion of empty space inside. The comet is physically large enough to produce a visible gas envelope of significant extent. It sublimates enough material to create a coma that blocks all optical detection of its core. But the actual solid mass within that volume is vanishingly small. The density of the nucleus is so low that the comet is, in the most literal physical sense, mostly nothing. When that mostly nothing object approached Jupiter at 61 kilometers per second, the kinetic energy of its motion was determined by both its velocity and its mass. The velocity was enormous, the mass was negligible. Jupiter's gravitational field extended outward and found almost nothing to act upon. The comet passed through the gravitational well of the largest planet in the solar system, the way fog passes through a gap in a wall. The surrounding space was affected, the comet itself was not. The gravitational ghosting of 3I Atlas at Jupiter was not a violation of physics. It was physics operating exactly as it always has on an object with a physical reality completely unlike what its appearance suggests. The apparent contradiction dissolved the moment the true nature of the nucleus was understood. Not a dense wandering ice mountain, but a fragile ancient ghost of frozen vapor and organic dust, enormous in volume, nearly empty in mass, carrying inside it the chemistry of a star system we will never find, and a history that stretches back to the earliest epochs of the galaxy. It drifted in from the darkness between stars, it lit up our skies for a few months, it sailed past Jupiter without leaving a footprint, and now it is moving back out toward the void, taking with it the secrets of wherever it came from, growing dimmer by the week as the sun falls behind it, until eventually it becomes invisible again, just as it was for billions of years before we found it. There is something quietly astonishing about that. We had one brief window to look at this object, and in the time we had, we learned enough to fundamentally revise our understanding of what an interstellar visitor can be. Not a rock, not a chunk of alien ice, a barely there structure of organic frost and empty space, carrying the chemistry of life, drifting weightlessly through gravity fields that should have bent it into a new path, surviving perihelion that should have shredded it, holding together through nothing more than fragile organic bridges and the cold patience of deep time. If you found value in working through this mystery from the discovery, to the chemistry, to the physics of the Jupiter flyby, please leave a like on the video. It is genuinely the best way to help this kind of careful, data-grounded science reach a wider audience. And if the story of 3I Atlas is one you want to keep following as new telemetry comes in, subscribe, and stay close. Because this object still has more to tell us before it disappears forever.